What is chaos engineering? Chaos engineering it's a discipline that involves intentionally introducing some failures or disruptions to test the behavior or the it's a stress test to so that we will intentionally introduce some failures here. We will bring down the system. We will bring down some parts, or so we'll bring down some VMs intentionally in the controlled manner, so that we will understand the how our system will behave here under this stress test. Okay, so here the goal is to identify any weaknesses in the system, and after that finding the weaknesses to further improve the system's robustness uh, before any real situation comes, a real world incident occur. So this is a pre-test where we will analyze, we will do the stress testing to identify the weaknesses of our system, of our environment. That is what chaos engineering chaos engineering looks for. Okay, uh, if we want to understand the key concepts in the chaos engineering, say for example, uh, we have it is a hypothesis driven experiment. Okay, chaos engineering. Okay, key concept, hypothesis driven experiment. Here the engineers will form hypothesis. That means before conducting experiments, engineers form hypothesis about how the system should behave under certain failure conditions. That's what hypothesis meaning here. Okay, then next comes the design experiment. Okay, under hypothesis only, hypothesis driven only. The design experiment, designed experiments are designed here to test these hypotheses in a controlled manner. They have control over these experiments. Okay, and these failures also, these are controlled failures. Here engineers will introduce controlled failures here in case something goes wrong, and if it is it's out of our control, then they should be able to roll back it. So that's what the controlled failure, immediately they can roll it back to minimize the impact on the production environment. They can roll it back. And it's limit blast radius. Okay, the scope of the experiment, what we are doing here, the cows engineers are doing here, it is a limit blast radius. uh, it is carefully controlled to prevent widespread disruption. Okay, and second one is so third one is observation and analysis here. So by doing this test, the cause engineering, whatever a disruption test we are doing here, the stress test we are doing here, first that the engineers will have the observation during this time, and they will collect the logs during this test, and engineers will analyze the logs. They monitor the system behavior. The system's behavior is very important here to monitor systems behavior. Okay. They gather the data here and then analyze the result collected from the collected data. That from that they'll understand the impact of failure and identify any weaknesses in the environment. That's what the advantage of collecting the data, observation and analysis. Okay. And the last step is a key concept. The fourth step, it's mitigation and improvement. So once we once the engineers analyze here and they observe the data and they analyze here, next step is to implement the mitigation plan or the improvement plan. So they implement fixes here based on the findings what they found in the during their analysis. So they implement the fixes here. Okay, and then whatever the weaknesses are identified during this test, so for that they have to find a fix and they will try to fix the weaknesses, and they implement the fixes. And next is improvement also. Okay, okay, so they have to improve the resiliency here. That's what the purpose of chaos engineering. They are doing here the test, stress test. So from that, wherever they find the weakness in their systems, so they will try to improve their. Hence, they will be improving the resiliency of the system. So the system will be more resilient to handle any similar failures that happen in the future. Okay, that is the resilience, improving the resiliency. Okay, and next comes tools and techniques in chaos engineering. There are multiple tools and techniques in the chaos engineering that are used to test the stress test or chaos engineering test. So one of that is the first comes chaos monkey. Chaos monkey, it was originally developed by Netflix. Um, what chaos monkey will do here? The chaos monkey, it terminates instances in production. Instances means VMs or your machines. It terminates instances in production so that uh, we can test by terminating the instances, we can test the stability of the environment to handle failure. Okay, randomly it will go and terminate any random instance so that we will test how uh, how resilient is how the stable is our environment even if any production VM goes down, how stable will be our environment. That's what it tests. Okay, it helps, again it uh, helps us to check or identify weakness and improve any automatic recovery procedures here. That's the cows monkey. Okay, that's the first tool. And we have another one, second one is gremlin. Okay, here gremlin, it provides a shoot up tools, okay, to simulate various types of failures, such as network latency or CPU spikes or any like instance termination as well as like a cows monkey. So any even instance termination as well it can do the gremlin. Okay, so it has multiple functionality. As I said, network latency is one. CPU spikes, it can suddenly hike the CPU spikes, introduce some CPU load here, and introduce some network latency here, or terminate some instances randomly, so that it allows uh, it allows cloud engineer to do experiments in a controlled manner again. Okay, this is also in a controlled manner. This is how engineer will do the test, cows engineering test using the Gremlin tool. And the last one is a litmus cows and cows mesh. These tools, we usually use it only for the containerized applications like Kubernetes environment. Okay, so they help us to simulate failures in these containerized applications to test their resiliency. So these are a few of the tools which we use in the chaos engineering. Okay, and next comes benefits of chaos engineering. See here, there are multiple benefits out of this by doing the chaos engineering test here, and the in that first one is increased reliability. So by identifying and addressing any weaknesses in the system, chaos engineering help us to improve the overall reliability of the system. And then the second one is proactive problem solving. Here, engineers can proactively address the potential issues before they become a real world issue or real world outage. So, engineers will proactively identify and solve it. That's the proactive problem solving. And the third one is better preparedness. We are better prepared to handle any real world incidents. So, and thereby reducing the downtime and improving any MTTR or what's that, mean time to recover. That's what we can do. And the last one is continuously improvement here. Chaos engineering, it postures a culture of continuous improvement and and proactive problem solving. That's what the culture here, chaos engineering culture. Okay. So these are the some of the benefits what I can say. If I want to say one real world example, Here, Netflix is a pioneer in cows engineering. Okay, when they moved from on-premises to cloud, they faced reliability issues. So to address this, they developed this cows monkey, the first tool what I explained as just now. They developed for this cows monkey, which randomly terminated their instances in their production system itself, in the production environment itself. So this helped them to identify weaknesses where they have and to improve their system's resiliency. So this is what uh, the real world example like what I can give. And here, finally, what I want to say is chaos engineering is a powerful practice that helps SREs and even DevOps engineers to build more resilient systems by intentionally introducing some failures and learning from them. So here, build, test, then learn and build. So you build it, test it using chaos engineering, resilience test, and then learn from it, then again rebuild it. So hence you will be improving your system's reliability, system's resiliency. That's what the intention of the chaos engineering is. Yeah. Thank you.